communities which make this possible? Well, I remind you once again to follow us on our social media, Twitter at ngconf, and we have the hashtag ngconf 2020. So please don't move. Our last block is about to begin with the last speakers. One of them is Alfonso Lopez. The floor is yours.
Ahora nos conectamos con Bogotá, la capital de Colombia, conocida por albergar museos populares, incluido el Museo Botero, que exhibe arte de Fernando Botero, y el Museo del Oro con piezas de oro precolombinas. Desde allí nos acompaña Alfonso López, desarrollador de software venezolano. Él nos hará una increíble charla sobre la creación de aplicaciones Angular utilizando server-side rendering, prerendering e internacionalización.
Server rendering, pre-rendering, and internationalization. Hello, Alfonso. How are you doing? Hello, very well. How are you? Excited, prepared, nervous? All of the above. Super. So here you're going to relax. So let me introduce you to Alfonso Lopez. As I said before, he's from Venezuela. He's a web developer. So the floor is yours. Thank you very much, Adriana. Okay. Good afternoon, everyone. My name is Alfonso Lopez. I'm a developer from Venezuela, and I will be talking a bit about the creation of Angular applications, thinking about server the creation of the Angular application, internationalization, to add multiple languages, server-side rendering, pre-rendering, and common questions which generally I would ask a person who's going to implement all these tools regarding the experience and working with them. What's next after all this? And then finally a demo. That's a table of contents. And as far as the open questions, surely this will answer some of the ones you might raise in the chat. So let's begin. Why implement SSR with Angular? Well, in order to answer this question, we have to go back in history. A few years ago, the concept of single-page application was presented, looking to make web pages, making them more dynamic, not just in pages, but through views where you would only change the portion of the code in the navigator so that it wouldn't be returned from the server, which gave user like an impression of it being faster. What happened? These produced certain disadvantages at the time of working with the single page application. What are they? SEO problem, because by then many robots were not capable of interpreting the Java script code and looking at the changes after the loading of the initial page of the skeleton and the initial loading time. It could be reduced a bit to the fact that all the set of components would be discharged or unloaded. Certain projects, you would see this before looking at the content, but once you had access to it, the experience would increase and improve much more. And amongst the tools that came about to develop this PA, we have Angular. Many years ago, it was launched, about 10 or more. And in the year 2016, the alternative of Angular came about. More than a framework, it's a complete platform where it encapsulates the framework. And one of the things it was looking to solve by then were those problems and the initial loading time. And that was done through an initiative called Angular Universal, which was an extension of Angular, which allowed to apply server-side rendering, which is the tool used to use or take advantage of of an application which would not be SPA, but with the power of SPA, without losing the characteristics which made it attractive or appealing. What was everything about? To have access to any URL, and with that URL, you would apply the technique of side rendering that returns the HTML. You would render it or have rendering, and after this, they could use all the characteristics of the SPA, and the routing would be done on the side of the navigator and not on the side of the server. So after this introduction, we will proceed to find out how to create an Angular application with all these tools. So the first step would be the creation of the Angular app. And this would be the simplest step of all. We will increase difficulty gradually. The first step is to use our preferred schematic, which is an ngnew. In this case, we will assume that we're going to create an application where we will implement all these features. And, well, it's not only an assumption, because it's really a project where all these changes were applied, the ones that I'm going to share with you at the end of the view graph. So there you see some flags to begin the project, and that is in charge of creating the Angular application. We can lift from the ngserve and observe the execution in 400. That's very simple. Now comes the part of internationalization. And as I mentioned before, this is the mechanism which allows you to add multiple languages into a web page and observe what's happening. What happens with this? This is nothing out of, or very uncommon, because it's documented in the Angular page. And to document this, we follow the steps on that document, which would be to use the schematic ng-add, Angular localize, which is in charge of adding dependencies to the project in order to be able to implement i18n. Amongst those changes, we see in the package, in the first page, adding the Angular localized package, and in the qualified.ts, it adds an importation. All these changes that we're observing based on this schematic were a change introduced after version 9 of Angular. Prior to this step was not necessary. Now, we need to establish certain conditions at the time of creating our Angular application. For purposes of this presentation and example, we're going to establish this in the view graph. The first one, implement the web page using all the language, English and Spanish. The second rule is we want to have access to the English page by default. That is, if I'm opening the local host 4200, by default, I should observe the page in English. Now, if I add path es / I will observe the version in Spanish. I will have access to it. How do we do this? Here, we need to do what the document describes for the implementation of this feature, and we can observe the modification in the JSON Angular file, angular.json file. What you can see there are the lines that we need to add, because to configure the behavior, the routing of the Spanish page and the English, in this first section, we established a local source, which would be English by default, and href initial would be the root, would be represented by this /. And we add the local ones, our page in Spanish, and we specify a file where you find the translation. At the same time, we add an ES configuration, which indicates that when the compilation passes this configuration, it applies location in Spanish. And when we do a serve, we add the same configuration so that it can be executed or run. Additionally, we add two additional lines in our JSON file. One is translate, which executes this command. And what is this command? It's basically an instruction of Angular which allows the generation of the file, the XLF extension file, where it extracts all the characters of the Angular application and will allow us to add the lines translated. And the view prop, which is a line that will serve to execute the compilation of the application with the localized flag true, which will allow the execution both in English and in Spanish. I mean the compilation. So to apply internationalization in our code base, we need to follow a set of steps. One would be to add i18n attributes to HTML code with an ID in order to be able to translate it. Once we do this in our code base, we execute npm run translate, where it will execute the XLF file to source XLF. Copy and rename it, and it extracts the chains in another source code. And what we do is we add the target label, which will represent translation of what you find in the source label, which is what you can see here in the first, welcome to X and X, and in the second one you see welcome to such and such. So what happens once we execute the nginx run build prompt? It will generate the compilation, and it will show us it will show it in this structure. In the nginx file, you see an N and an S folder generated applying this in Spanish and in English. What comes after this? Both pages are totally independent. So basically, these can be served in an individual way, or use some external service depending on how to be charged, in charge of having access to one or the others. That's what you would need to do. And what happens? I would like to show in this view some of the differences between the English and the Spanish version, for example, of index.html, and we can observe it in the green part. We can see the LAN attribute that you see in English and the other one in Spanish. This was present in the version 8 of Angular, and then it was solved. And href, which is what we use to specify from which URL we want to have access to the specific version. In English, we have the slash, and here we have the S. Now, how do we show this? Well, for purposes of this presentation and the example, what was implemented was an nginx server. This image, it is in charge of making or routing in the route or in /s in order to load the specific page. In English Docker, what we do is we use nginx image, the configuration that you see up here, and we copy the content, static content of this application to a folder within our Docker image. And with this, we can see our application running. If we executed 5000 the way you see it in this picture, that was the port exposed or shown in the prior configuration. And when we click on /s, we can observe the version in Spanish. There's a typo there. I'm sorry, I didn't solve it afterwards. So, yeah, have it implemented in an Angular application. application. So far, nothing beyond normal, different from the normal common thing. So now we have the server-side rendering. How to implement this in an application which already has the i18n. Before mentioning this, I would like to talk about the strategy, the server-side rendering strategy, and what it really means. What it seeks to do is it wants our Angular application to be applied on the side of the server. And the back end, we want it to return as an answer. The HTML should be completely renderized, which is done normally on the side of the navigator. So that's the strategy we want to implement. How do we do it? Well, first execute the schematic of Angular according to the documentation in universal / express engine. And what it does is it will add new files in our source code and modify the existing ones. I'm going to show you the most important ones. The first modification is Angular JSON. We can see 3 objects it adds within the architecture. Some in server, some in SSR, and the other pre-rendered. The first one represents the configuration which will allow us to compile our application on the server side. And the second one will allow us to make server in the mode of development. And the third one allows us to apply pre-render in our Angular application. These last 2 characteristics or features were introduced in version 9 of Angular. The first one, the server in local mode, where it was introduced because in prior versions, in order to execute the application on the server side, you have to make a build in production mode, and it would take some considerable time. Changes were made on the base of the code. You would have to compile once again the application, and this facilitates the development and pre-render. In order to apply this technique at the time of working with our web page or pages. Second file. This file is a server.ts. It exposes an express server with a set of predefined routes, where it allows you to deliver static assets, which is what generates a build of our Angular application. And it allows us to renderize our application through the calling a function in gexpress engine, which works in the library of Angular Universal. So it's this function specified in the initial mode, which will be in charge of renderizing and generating a string with HTML, and it will return it to our client. Another modification made by the schematic is that it adds certain scripts, one for the development, another one for the development mode, another one to build the application in production, and another one for the pre-render. Having looked at the line with the schematic, which modified is we can next render and CSR, which would allow us to build the application. However, this will only work in English for a new application, not working in Spanish because it has not been. So how do we integrate this with the server-side rendering? There are 2 ways. One, you usually see is using 2 node servers running on different ports in the reverse proxy configuration depending on the language. And the second option is you can use just 1 node server running on a single port and using the same reverse proxy configuration. Well, not the same one. You see highlighted the second option. It's 1 and 1, 2. The one where to work in the server-side rendering was adjusted more to this second strategy, and it was allowing us to make not such major modifications. So we chose the second one because of that. So what are the steps? The steps would be to add two development dependencies, TS Loader and Webpack CLI. Why two? Well, it turns out that prior to Angular 9, that is in Angular 8 and before that, in order to do server-side rendering, you added a configuration file of Webpack, which was in charge of compiling only a server.js. But in the Angular, internally, it was in charge of compiling the Angular application as such to be compatible with applications on the server side. So when I would compile the server side, a build was made in the application for another build made for the server side, and another build would be made through the Webpack configuration for the server.js file. What happens in the version? This last compilation was eliminated, and it's done now internally in the pipe. So that's why we're basing ourselves on the Angular 8 version. It was easier to implement this. That's the reason. So another step is to add routing configuration file. Another one would be to have a minimal refactoring the server.ts file, minimal changes related to main SSR file, and scripts in package.json file. So the first step, add routing configuration file. What you do here is add a new file. We can call it static routes, where you specify the paths associated to our explanation in Spanish and in English, and what you're going to specify also is the bundle where the specification will be extracted both in English and in Spanish. A minimal refactor in the server's live file is the one we see with our friend cracking, where the significant changes are the following. You add an additional line where you will be able to load the application in English from the route, and the existing one will be used for Spanish. The nginx configuration was modified, Express Engine, and you also see a modification in the one in charge of the route for the server side. These are minor modifications that you will find in the repository that I will share later, and remove the instructions that being there prevent the server from executing with the modification that we're making. So those are eliminated. Minimal changes to the main SSR file. So we here see that we're modifying the angular.json to remove the initial file. And what we're going to do is compile these based on the main.server.ts. This based on the configuration of Angular 8 application. And we add this line, the main server.ta, which is the same one from Angular 8. Oh, we see it cut here. It's not complete. Well, what we do here is we modify the build and the server-side rendering lines, where we added first, the server-side rendering will no longer execute as initial file in main.js, but in the server with the same configuration. And in the build, we're going to add the localized and the run compile server. That's the one that will be in charge of compiling the server.ts from the web. And here we modify the ng build prod to be able to add the npm run build prod, which executes this but with localized. So this applies also for the compilation type of Angular CBAC. So once this is done, well, you cannot observe this clearly here in the view graph, but it changes the way 118n is generated. The server will create a file NES with a main.js with all the artifacts of the respective language. The same thing will happen for English and for Spanish in the front end. We here can see an image of the compilation pipe once it's executed. An N file, I already mentioned it, or sorry, folder, and a server folder, an ES folder. For the people who are observing this image, you will realize that the files generated have the same channel. This is, I'm sorry, the sound is not very good. It's been cut. This is the one producing the same caches, and here's the axis, and this is the title. It's worth mentioning because the way the Angular application is displayed, it can generate conflicts that so that these fonts might have it all depends on the way you see the display. So basically, we the SSR we're going to the node server, and we will have access to the page both in Spanish and in English. Why? Because it runs this server.js file that you see. Well, you don't see it, it's the last one. Here we can take a look at a capture of it running, and in the lower part you see the content already renderized coming directly from the server. So, for purposes of the example, what was done was a Docker configuration Docker compose, where it will link the nginx server, and at the same time it created an image with a static application of Angular. What happens? So now we have server-side rendering in our Angular application with the node server. Now to lift our application in production, we use the node server, which runs through the command that we can see here in the Docker file. It's the same one in the JSON package. So we prepare the Docker image with another node image. We copy the content within the image, and we leave the server exposed to port 4000. And what we do in the upper part, default cond, we establish a proxy application in order not to expose our node application outside, and so that all petitions come to a specific port, 5000, or in any case it could be 50 or whatever you need to use, and then it will be internally sent to 4000. And the proxy pack, which is the one in charge of the configuration, this is a very simplified file. Obviously, we need a few things to take this application to a production environment. So we have this implementation already in an Angular application, pre-rendering. Before indicating how to apply or implement pre-rendering, it's important to find out about the concept. And this is a strategy which allows us to generate in build time the HTML static views and save them in files of our filing system, so that when we make a deploy to production and we want to have access to a URL, you don't apply the server-side rendering. So what it will do is obtains a file from our filing system, it reads it, and it returns to the front end so that the navigator can renderize it. And the advantage is that the pre-rendering is a technique which works much quicker than the server-side rendering, because server-side rendering is executed in runtime, while pre-rendering is in build time. You don't need to make any additional process when you have access to a URL. So how to do it? For this case in particular, I want to tell you about something. The experience maintaining Angular applications with the server-side rendering comes from Angular 8. For example, we're talking about a combination was made with the knowledge acquired with the 8 version, plus it was combined with the implementation in the recent version, which is number 10. Since it was an application for Angular 8, the pre-rendering strategy by default was not introduced yet, and by then they didn't have tools like Scully, which was the one presented in the prior presentation and in the workshop yesterday. So in this case, what we had to do was a rudimentary implementation of the pre-rendering. Why rudimentary? Because we can see that in order to create this configuration, the first thing we do is we add a route, the route that we specify to implement the server-side rendering. And in this rudimentary implementation, we would each one of the routes we added each one of the routes. Why rudimentary? Because, for example, the implementation of Angular 9 pre-renderings, Scully makes the discovery of routes in the application through library gets parser, which was created by people who will make the presentation after. So, since this was not used then, we had to resolve it this way. Now, can you imagine signaling children routes, one for Spanish, one for English? For this example, we're only using one array. However, here we added two, because in the implementation then, we allowed to apply i18n also for to route or for the routing of the application, and I will talk about this a bit later. So apart from these modifications in the Webpack file, we also used this line to use the same compilation of server TN in order to compile TS, and the next step implementation of prerender.ts, which is a very small file, similar to that of server.ts. However, what we do here, what we see here is that when executing the script for render command, once it's compiled, it makes a journey, like what we showed the priority method for each one. It will call the engine, which is the function in charge of or associated to the GF Express engine in charge of generating the stream for the application. So it does this basically. It makes the journey, it executes for the specified route, and it puts it in our filing system. That's what this file does. The next step is to add surgical modifications to our server.ts so that it can evaluate whether the route that is being requested is pre-renderized or not. How do we know? Through the array with status of route that we keep adding. If it's pre-renderized, it goes into the condition and calls the pre-render function. It returns it, and this HTML is sent to the navigator. If it doesn't exist, it will proceed to apply the server-side rendering. So, at the same time, what we do is in the package JSON, in the pre-render SSR, we have an additional instruction. The one you see in green, what it does is the build is executed in production mode, both in the web and in Node or as it executes the pre-render file, which is in charge of generating the HTML and save it in the output folder. So that will make an application Angular operate automatically. This is a summary of how to apply this type of application. How come to this session of common questions raised at the time of working on this. These are questions that I imagined might help you understand what happens when we work with it. So the first one is, how expensive and complex is it to implement SSR in existing applications? It always depends. Generally, it tends to be kind of complex. The greatest enemy at the time of implementing SSR is the access to Doom, the Doom of our Angular applications. In our code base, if we have this type of access without sufficient care, that might make other applications explode on the side of the node. Or if it's going to be referenced, we would have to prepare a patch. When it's a large application, we use a large number of components, modify and execute it with algorithms specifically so that can make an application explode. So depending on the size of the application and the architecture, it might be expensive to implement SSR in this type of application. The second one, how expensive is it to maintain Angular applications with server-side rendering plus pre-rendering plus i18n? What happens? To the extent that time elapses with this type of applications, maintenance becomes easier because developers um, start acquiring knowledge as to how to maintain this type of applications. It helps improve some practices in programming. However, something that is unquestionable is that it does increase the cost of maintenance in an application because it generates more acceptance criteria at the time of working with these applications. It increases the test times. You have to make sure that it works not only web, but the backend. Leaks of memory have to be taken into account, amongst other things. So it could increase the time, the development time for applications of this sort. The other one, can I use a pre-rendering strategy that Angular brings by default? Yes, provided that the features demanded by the business are adequate or suitable for the pre-render. The important thing to know is that apart from the pre-rendering strategy supplied by Angular by default, there is the rudimentary manual implementation that can be used in an extreme case, and there's also the Scully tool, which facilitates pre-rendering with this type of application. Another question is, what can I do with pre-rendering in an Angular application? What can I do? Well, in pre-rendering, it allows us initially, the first thing I can think of is it allows us to generate HTML of the views that are totally static. This helps us a lot. You can also use pre-rendering to generate partial views of the same one. Example, imagine you have a view where the results you want to execute the results on the side of the client, but you want to pre-renderize the skeleton of the entire application. So what happens with this? Angular provides utilitarian functions which allow to specify or execute code either on the server side or on the client side. So this would allow us to do pre-rendering. It can also be used to detail information, but if information changes constantly, this can make things complex as far as maintenance and creation of these infrastructure views based on dynamic information. In which case can I use server-side rendering on pre-rendering? One particular case could be
One particular case could be a view relative to the entity and this information, if it changes very constantly in a way where we have view where the information changes every so often, then in theory it could be simpler to implement server-side rendering than pre-rendering, because pre-rendering changes very constantly, and this would be perhaps in terms of time costly to implement, and also provide tools for this type of thing. The pre-render. What about performance in this type of application? Spectacular. Work with applications with server-side rendering and pre-rendering improves the performance because it reduces the initial load and it makes it insignificant. So with server-side rendering, it's very fast because the user is going to perceive when, and doesn't have to wait for the Angular application to change and render. On the side of pre-rendering, even better, because you take the file from the disk and deliver it to the browser, and that reduces a lot your time. But what about the impact in terms of resources with a server-side application? This is where things get complicated. What happens? Well, one of the things that make it difficult for this maintenance is the fact that you have to be looking after things that normally you're not used to. Like I said, one of the main things is access to variables like Windows, but another very important thing is to be looking out for memory leaks. So a very simple case, or particular case, is leaving an observable open in the side of our application, and when a node is executed, it accumulates as far as we continue. So the consumption of the application is going to grow too much and get to a point where it is not maintainable. What happens? To be able to treat this problem, a solution that was applied back then was to use a strategy of microcache in our nginx server. So we would reduce the amount of heat on our node server, because if we have, for example, if we're on page 3, and when you hit 5, then you have the generation of that HTML. So that is going to cause the consumption of memory to trigger when a number of users go into the page. And it could be a slower access to the page because of the rendering. So what we do is, when that is exceeded, then you apply runtime. That cache is saved in nginx through a specific time and establishing a maximum memory size. And this would obtain the information of what is in nginx. Now, what I'm telling you about nginx was a solution for us, a definitive solution for us to control the problem of memory and excessive consumption of resources. So this strategy facilitated for us to use server-side rendering and pre-rendering. An additional point regarding what I'm saying is, or regarding pre-render, is that it helped us to determine if an application is working with server-side rendering or not, because since this is executed in build time and this is continuously integrated, it fails, and we know that there's a problem. What about HTTP requests executed in SSR or pre-rendering? Well, this is very interesting. A simple implementation executes the requests in server-side rendering, pre-rendering. It returns the HTML, but once the Angular application starts, it's going to try to do the same request to an external service. So it's going to hit it twice. Well, Angular provides a transfer space together with the universal Angular package, which is added to the module. So this uses an interceptor, which is in charge of serializing the node, the request in HTML, and the browser, when the client executes Angular, transfer state has the serialized HTML to avoid hitting that external service again. And an important detail that happens with this type of things is that, well, what happens if you are making requests to an external service, which is a library it supplies, and it is outside, and it's not executed through the HTTP client service in Angular. So in this case, this through the transfer state would not be done, and the challenge that had to be solved was to check the implementation of the transfer state as the interceptor and do a custom implementation for this library that hit directly this service to solve the issue. Is it possible to implement 18n in routing? Yes. Prior to Angular 9, it was difficult because, as we well know, when we injected services through the providers, it allows us to use functions, factory functions. In Angular 8, there was a book that didn't allow us to use factory to create the routes in a dynamic way real time because it generated an error. But this was solved in Angular 9. So to implement this i18n routing in Angular, we use environment files similar to the ones existing, but with a Spanish-English constant and build time, selecting what route would be used or not. With Ivy, you can already use the functions, the factory functions to specify the routes, so it facilitates the implementation of i18n in routing. However, to implement this adds complexity to the application. And you have to have a very special or robust order when working with this route in our application. My page is adaptive. What can I do? Well, this is a use case that was very complicated because to determine that a page is adaptive, if it's using the same Angular application, regardless if it's the right strategy or not, through the same URL, you could have access to two versions of the page, mobile or desktop. If you include tablet, that's great. But the thing is that this is based on the user agent. To implement this is very cumbersome because you have to, well, first add logic so that in the pre-render, it generates not just the HTML in Spanish or in English of those pages, but also a mobile version, desktop version in Spanish and in English for each of those. So you have to modify the logic so that this works in the pre-rendering. And in addition, you have to mock the request variable in Express, which is where you have the insert agent so that when this is executed, it takes that chain of characters and then does the corresponding generation. And on the side of the server side, then you also have to add logic, custom logic, which is complex to read this user agent and determine what you need to render and what not. In fact, back then, there was a library used for this, and you had to apply a hack on that to make it compatible to server-side rendering and to correct the user agent and do the corresponding render the way it should be. Can SSR be implemented in the private part or an application? Well, I would not recommend it. Like I said, server-side rendering adds responsibilities and more complexity when working with our applications. And personally, I do not justify implement this in the private part because it does not, it would not be worthwhile the amount of effort in working with the applications unless the business so requires. But that's a different story. So we have 1 minute left to give way to the next talk by me. So yes, what's the next thing to do? Research about the Scully tool because it has improved a lot in the past months. It's grown very quickly. So this is something that we have to research for implementation to test the integration of the tool and also to increase the speed to increase those criteria and to speed up the deployment of server-side rendering. So the next step would be the demo, which would be through this link that was already made public. I'm not going to show it, but you have to go to the application with the public strategies. I mean, first maybe I got involved as a developer, and that made me grow like I have no idea. So thank you so much, guys. Thank you, Alonso, for this excellent talk. Did you have fun? Think you were nervous anymore? Yes, of course. When I put on my thing, I'm not nervous anymore, and I'm just explaining what I know.